Parametric equations. Parametric equations are just functions in the form of t. Easiest way to work things, a parametric equation out, is if you're given a Cartesian equation out, if you're given a parametric equation, is to rearrange one of the equations and substitute it for t. If you want to find the parametric equation, then you find the equation as normal, then let x equal t, and then write it in terms of y in terms of t. Right, so for this one here, part A, we've got to find the Cartesian equation given these parametrics. So for this first one, I'm going to rearrange it so I get t equals x minus 2. And now I'm going to sub that into that equation there. So I get y equals 2x minus 2 minus 3, which means I get y equals 2x minus 4 minus 3, which means I get y equals 2x minus 7. That's the Cartesian equation. Part B, I want to find the parametric. I only have 2 points. So let's find the normal equation of this line. So gradient 7 minus 3 over 4 minus 2, which means I have 4 over 2, which means I have 2. And then I use the equation of the line. I'll use this one here, and I get y minus 3 equals 2x minus 2. Y equals 2x minus 4 plus 3, so y equals 2x minus 1. And therefore, having this rule as a Cartesian, I can say parametric, let x equals t, and we get y equals 2t minus 1 becomes the parametric equations. Parabolas, we do the same thing. We've got to find the Cartesian equation. So for the first equation, I get t equals x plus 1, and I substitute it into this equation here. So I get y equals x plus 1 squared plus 1, which means I get y equals x squared plus 2x plus 1 plus 1. So I get y equals, I should have left it. Get rid of all that. I'll just leave it like this, because that's as a parabola already written. Circles. Now circle, this is the general equation of a circle. X squared plus y squared equals r squared. We introduce parameters. We get x is that and y is that. Now, which means we can get, instead of the Pythagoras theorem, cos squared theta plus sin squared theta equals 1, we've now got it in terms of t. Example 18, find the Cartesian equation of the circle defined by this. So what we're going to do for this one here is we're going to rearrange to get cos t and yt. So cos t equals x minus 1, sin t equals y plus 2, and then using the theorem, sin squared t plus cos squared t equal to 1. That's Pythagoras theorem. I know what sin t is. I've got y plus 2 squared. I know what cos t is. X minus 1 squared equals 1. So I'll leave that one like that. Part B, parametric, given this here. So x plus 1 squared plus y plus 3 squared equals to 4. Now just remember that cos t, when rearranged, is the x value divided by the r, and the sin t, when rearranged, is the y value divided by the r. In this case, my x is x plus 1, and my y is y plus 3. So substituting that in, I get cos t equals x plus 1 over, now that's r squared, so r equals 2, so over 2. And sin t equals y plus 3 over 2. Rearranging this to get x equals 2 cos t minus 1, and this one here, y equals 2 sin t minus 3. So there's the parametric equations. Ellipses, same thing. There's the parametric equations, which we can use this as well. And then again, the rule, x squared plus divided by a squared plus y squared divided by b squared gives us the identity rules as well. So example 19, part A, Cartesian equations of this. So I'm going to rearrange this one and have cos t equals x minus 1 divided by 3, and sin t equals y plus 1 divided by 2. and then using the rule which says cos squared t plus sine squared t equals 1, I'm going to get x minus 1 squared divided by 3 squared. Now I'm just going to leave it as 3 squared because remember the original rule for this says x squared divided by a squared. And I get plus y plus 1 squared divided by 2 squared equals to 1. Part B. Parametric equations given this. X minus 1 squared divided by 4 plus y plus 2 squared divided by 16 equals to 1. Use the rules cos t equals x divided by a, sine t equals y divided by b. There's my x. And a is the square root of this number, which is 2. There's my y. And b is the square root of this number, which is 4. So I get cos t equals x minus 1 divided by 2, sine t equals y plus 2 divided by 4. Again, rearranging to make x the value here, 2 cos t plus 1, and here y equals 4 sine t minus 2. Hyperbolas, similar thing, there's a minus in there, squared down the bottom here, still using the rule, but it's negative this time, and it's sec squared t minus tan squared t equals to 1. We'll need this, and that is the same. So, example 20. Find the Cartesian equation of a hyperbola defined by the parametric equation. So part A over here, again, rearrange it, and I get sec t equals x plus 1 divided by 3, tan t equals y minus 2 divided by 2, and then I've got the rule of sec squared t minus tan squared t equals to 1. Again, I'm not going to square the denominator, I'm going to leave it with just the squared there, so I get x plus 1 squared divided by 3 squared minus y minus 2 squared divided by 2 squared equal to 1. Part B, the other way, parametric, x plus 2 squared over 4 minus y minus 3 squared over 16 equals to 1. Okay, so I'll just write the rules down. Sec t equals x over a, tan t equals y over b. There's my x, 2, y, 4. Okay, I'm ready to go. So I've got sec t equals x plus 2 over 2. And I've got tan t equals y minus 3 over 4. Rearranging, I'll get x equals 2 sec t minus 2 and y equals 4 tan t plus 3. Now, parametric equations with restricted domains. Eliminate the parameter, that's what it says, to determine the graph. So if I eliminate it, I've got to get rid of the t, so I've got to substitute one into the other. So I'm going to rearrange this first one and get t equals x plus 1, and I'm going to substitute it into number 2 and get y equals x plus 1 squared minus 2x plus 1 plus 1, which means I get y equals x squared plus 2x plus 1 minus 2x minus 2 plus 1, which gives me y equals x squared. Now t is between 2 and 0. I've got to find the x. I'm going to use this to find the x. When t equals 0, I get 0 minus 1, so I get negative 1, that's less than equal to x, less than equal, and 2 minus 1 is 1, so that's the restricted function there. So if I was to graph this one here, you know me and my graphs, x, y, there's my 0 there, negative 1, 1, 1, this one, negative 1, 1 is y, 1, 1, 0, 0, so it starts there and finishes right there. There's that graph there. Intersections of curves defined parametrically. So if we're going to find the intersection of these two things, a circle and a line, it might be best to rearrange it in terms of Cartesian and then be able to do it. So for the circle, if we rearrange this one here, or work this one out, remember circle is x squared plus y squared equals r squared. This is my r, that's my r, so I get x squared plus y squared equals 25. The line, first one, I will rearrange t equals x plus 3 and substitute it into the equation here. So I get y equals 2x plus 3 minus 8, which means I get y equals 2x plus 6 minus 8, which means I get y equals 2x minus 2. And now I want to find the intersection between this line, circle, and this line, so I'm going to substitute one into the other. So I get x squared plus 2x minus 2 all squared equals 25. So x squared, 4x squared, minus 4 is minus 8x plus 4 minus the 25 equals 0. So 5x squared minus 8x minus 21 equals 0. Factorising 5x equals 0. This gives me plus 7 in here, minus 3 here. Therefore, x equals negative 7 on 5, or x equals 3. I've got to find the y part. Okay, so I'm going to substitute it into here to find the y part, and I get y equals 2 times negative 7 on 5. So it gives me y equals negative 14 on 5, or y equals 3 2s are 6 minus 2, which means y equals 4. So the points are x is negative 7, 5, negative 14 fifths, and 3 and 4. You can do it on the calculator by going to graphs, typing all these into there, and you'll get that graph there.